Assalamualaikum and very good morning to both of my panels and my fellow friends. My name is Nura Ashida binti Ibrahim. Today I will be presenting my final year project titled Antibacterial and Antifungal Activities of Green Biosynthesis of Silver Nanoparticle from Moringa aloe vera leaves. Today I would like to discuss the growing problem of the microbial resistance. We are facing a significant crisis with a rising antibiotic resistance as highlighted by Singh and colleagues in 2019. This challenge is compounded by persistent fungal infection, which this issue underscored the urgent need for innovative solution in healthcare and infection control. Next, we will introduce you how Moringa aloe vera, a tree native to India, can be used to synthesize silver nanoparticle to tackle this issue. Problem statement. Microbial resistance is a growing concern in healthcare, necessitating the development of novel antimicrobial agents. Traditional methods of synthesizing nanoparticles often involve toxic chemicals which can be harmful to both health and environment. Hence, green synthesis method, which use plant extract as a reducing agents, are gaining popularity. The key issue addressed in these studies are: the first one, can silver nanoparticles AGMPS be synthesized from Moringa aloe vera leaf extract? The second one, how can the chemical and physical properties of this AGMPS be characterized? The third one, do AGMPS exhibit significant antibacterial and antifungal properties? The objectives of these studies are: the first one, to synthesize AGMPS using Moringa aloe vera leaf extract. The second one, to characterize the physical properties of synthesized AGMPS using UVV spectrophotometer. The third one, to evaluate the antibacterial and antifungal activities of synthesized AGMPS against the various pathogenic bacteria and fungi. Now let's dive into literature review. Moringa aloe vera is native to India and grows in tropical and subtropical region. It contains bioactive compounds such as flavonoids and alkaloids, which are effective against skin infection. Nanoparticles are microscopic particles with unique properties vital in biomedical application due to their non-toxicity and effectiveness as antibacterial agent. Silver nanoparticles in particular are preferred for these properties. Using Moringa aloe vera as a reducing agent in the green synthesis of AGMPS offers several advantages. The plant facilitates the conversion of metal ions to nanoparticles and acts as a reducing, capping and stabilizing agent. Now let's dive into methodology. First, Moringa aloe vera leaf extract was prepared and freeze-dried. The extract was used for the green synthesis of AGMPS at 60 to 90 Celsius using an aqueous solution of silver nitrate. The solution color then was changed from light yellow to dark brown. Then the synthesized AGMPS solutions were characterized using UVV spectrophotometer. And lastly, the bacteria and fungi were cultured and their turbidity was measured. An antibacterial susceptibility test was conducted against several bacterial strains, which are Escherichia coli, Staphylococcus aureus, Bacillus cereus, and Salmonella typhimurium. An antifungal test was performed against Candida albicans. Here are the results and discussion. Let's start with objective 1. The MO-NGMPS solutions were heated at 60 to 90 Celsius with continuously stirring for 1 hour. During this process, a notable feature of AgNO3 solutions, appearing color change from yellow to dark brown, indicate the accretion of AgMPS. Bioactive components like phenolic acids, flavonoid and other reducing agents in Moringa aloe vera facilitate the reduction of Ag ions to metallic silver. This reduction process is accompanied by the nucleation and growth of AgMPS, leading the formation of colloidal silver. The size and stability of the resulting nanoparticles are influenced by temperature, which also affect the rate of nucleation and reductions. Darker solutions typically correspond to the higher concentration or larger size of nanoparticle. Therefore, the change from light yellow to dark brown serves as a visual confirmation which synthesis of AgMPS was successful. It indicates the complete reduction of silver ions and the formation of stable nanoparticles. My findings was aligned with those ordered Kazemi 2023. To further validate the formation of AgMPS, UVV spectrophotometer were employed. The temperature during the synthesis of silver nanoparticle can significantly influence their size and distribution. Throughout the characterization of this nanoparticle, important for understanding their properties and ensuring their efficiency in various applications. Among the special optical characteristics of AgMPS is a surface plasmon resonance (SPR) band in the electromagnetic spectrum's visible range. The SPR peak position correlates with the size of AgMPS. The higher shift of SPR peak position indicate the larger size of nanoparticle. A characteristic absorption peak around 400 to 450 nm confirm the presence of AgMPS and provide information about their size distribution. In this study, it has been proved that temperature 60 to 90 Celsius is the optimal temperature for silver nanoparticles to form as the peak fall within the desired range. The broadness of the peak indicate the presence of the polydispersed nanoparticles as discussed by Ibrahim 2021. The disk diffusion method was used to evaluate the antibacterial activity by measuring the diameter zone of the inhibitions. To ensure accuracy of experiment, it will perform in triplicates. From the result above, it shows that AGMPS effectively inhibited the growth of all tested bacteria strains, confirming their antibacterial properties. However, the inhibition zone for AGMPS were consistently smaller than those for the positive control chlorphenicol. This suggested that while AGMPS have antibacterial activity, their efficiency is lower compared to conventional antibiotic, which could be due to several factors. The concentration of the AGMPS in the disk might have not been insufficient to produce inhibition zone comparable to those chlorphenicol. AGMPS and chlorphenicol operate through different mechanisms. Chlorphenicols inhibit protein synthesis by binding to bacterial ribosome. In contrast, AGMPS generate reactive oxygen species ROS and interact with cellular components, which might be less effective at lower concentration or require higher doses for significant impact. The effectiveness of AGMPS varied between gram-positive and gram-negative bacteria. Gram-positive bacteria, B. cereus and S. aureus, show slightly larger compared to gram-negative bacteria, E. coli and S. typhi. For example, Bacillus cereus had zone up to 1.1 cm, while Escherichia coli had zone consistently at 0.7 cm. Based on the study from Pragati 2023, gram-negative bacteria have a thick LPS layer in their cell wall with a thin peptidoglycan layer, which reduces the chance of AGMPS penetration into the cells. In conclusion, AGMPS at a concentration of 100 mg/ml are most effective against Bacillus cereus as it has the largest dose compared to the other bacterial strains. The disk diffusion method was also used to evaluate the antifungal activity by measuring the diameter of the zone of inhibition. The mean inhibition zone for 7 nanoparticle against Candida albicans was 10 mm. This consistent inhibition zone indicates that AGMPS exhibit significant antifungal activity against this fungal strain, likely due to their ability to disrupt the fungal cell wall and interfere with the essential cellular processes. This confirmed the potential of AGMPS as antifungal agents. However, the antifungal activity of AGMPS, which are the inhibition zone, was smaller than those produced by the positive control ketoconazole, which consistently measured 15 mm. Similar trends were observed in the literature from Salari and Mosavi 2017, where the conventional antifungal agents outperformed the AGMPS. The factor influencing the antifungal efficiency include the concentration of AGMPS, the release rate of the silver ion, and the particle size. If the AGMPS used in the study were relatively large or unstable, it could have reduced the antifungal efficiency and result in smaller inhibition zone. In conclusion, this study demonstrates that Moringa aloe leaf extract can be used to synthesize AGMPS through a green, eco-friendly and cost-effective method. These findings highlight the potential of green synthesis AGMPS as effective antibacterial and antifungal agents for biomedical and industrial applications. Recommendation for the study: the first one, use advanced characterization technique like TEM, SRD or FTIR to better understand AGMPS properties. The second one, optimize the parameter of the green synthesis process such as pH, temperature and concentration of the Moringa aloe extract and AgNO3 to maximize the yield and the efficiency of the AGMPS. The third one, carefully monitor the optical density of microbial cultures to ensure the accurate measurement of the growth inhibition. Variation in OD can affect the interpretation of the antimicrobial activity, so standardizing this parameter is crucial for consistency. That's all from me. Thank you.